Let me first welcome you to class in elective maths on the topic calculus. Your facilitator for today is Brainbox. We begin with limit of functions. The limit of function x is equal to L as x approaches a. This means that we can only find the value of L when we substitute values of x around or closer to a into the function. Let's begin this practice. In this example, the function given is x cubed and the limit value of x is 2. So with 2 at the center in the table, the numbers around or closer to 2 are 1.9, 1.99, 1.999, and behind it we have 2.001, 2.01, and 2.1. Now take your calculator and verify the cube of the x values we have computed. You could see that as we get closer to 2, that is from 1.9, 1.99, 1.999, getting closer to 2, then the function is also getting closer to 8. So we conclude that as x approaches 2, the function is also approaching 8. We write this as the limit of function x cubed is equal to 8 as x approaches 2. Let's take another example. In this example, the limit value of x is 1. So choosing numbers around 1, we choose 0.9, 0.99, 0.999, then we skip the 1, we go to 1.001, 1.01, 1.1. So if you substitute these x values into the function x squared minus 3x plus 4, you could see that as x approaches 1, the function is approaching 2. So you write the limit function again and equate it to 2 as the answer. Can you practice the following examples? Now do this yourself. I believe you are able to do the exercise. Good job. Now, without the table, you can also find the limit by substituting the value of the x into the equation. Let's look at the following examples. In this example, the limit value of x is 2. So replace x in the function with 2 to get the answer 4. Follow the following examples. If the function is a rational function, check to see if when you replace the limit value of x into the denominator, you won't get 0. If you will get 0, then you have to simplify the rational function such that the denominator after substitution won't give you 0. In this example, when x is equal to 1, the denominator won't give you 0. So there is no need to simplify. But in this example, the denominator will give you 0 if you don't simplify. So you have to simplify it before substituting the value of the limit function x. If after the simplification and the denominator still gives you 0, like the example 3 letter E, then the limit does not exist. And if the limit value of x is infinity, like in this example, then you simplify the function by dividing each term by the highest x degree, that is s squared. So in this example, you could see that 5s squared is divided by s squared, and then 8x is also divided by s squared. Negative 3 is divided by s squared. 3x squared is also divided by s squared. So you cancel out to simplify. After that, you put x to 0 to give you the final answer. Let's turn our attention to the formula of the differentiation of the first principle. We are going to look at how this formula is deduced. Please revise on finding the gradient of a straight line. It will be very useful to us in this lesson. Now let's consider this graph. We have the blue curve as the graph of the function, and we have the straight red line AB. Now the coordinate of A is x, fx, and that of B is x plus h, fx plus h. The h is the small increment added to A to form the B. Now we can find the gradient of line AB, which of course we know that gradient is change in y over change in x, or y2 minus y1 all over x2 minus x1. So following the gradient formula, we get change in y on change in x. So the y2 minus y1 on x2 minus s1. Sorry, the c supposed to be h. So when you make c h and you open the bracket for the denominator, the x cancels out and h will stand alone. This is the formula for the differentiation by first principles. You only remove the gradient from there and put dy dx, or first derivative, or the limit function. They all mean the same thing, the gradient. The limit is there to tell you that we took the limit of the gradient as h approaches 0. Now let's come to how to apply the formula. Let's first look at this example. The function given is x squared. So you square the numerators of the formula, and then you simplify it. When you are done with the simplification, you put h to 0. Please note that where you have to simplify, the h is separate for 2xh and h squared. Let's look at another example. Here the function given is 3x squared minus 5. Please follow the steps carefully and understand each step. I believe you are following. Good job. Now you have this as your exercise. Now let us turn our attention to how to differentiate polynomials. In this polynomial, each x has a coefficient and a power. The constant 3 also has x, but the power is 0. That is why we don't write it. Now to differentiate this, multiply the power by the coefficient and reduce the power by 1. Note that the constant 3 has x to the power 0. So 0 times 3 is 0, and that term goes away. Note that anytime you differentiate a constant, you get 0. Let us look at another example. In this example, you are going to differentiate each term. So when you differentiate 3x squared, you get 6x. Then when you differentiate 2x, you get 2. But when you differentiate 1, you get 0. Note that the power multiplies the coefficient, and the power is later reduced by 1. If you differentiate a polynomial, your answer is called first derivative. You can differentiate your answer again, and your new answer will be called second derivative. you can still differentiate it again to get the third derivative and so on. Look at this example. Now, do well to go through the following exercises. Let's turn our attention to the rules of differentiation. Now, the constant rule says that anytime you differentiate a constant, you get 0. The power rule says that multiply the power by the coefficient and reduce the power by 1. We are now going to look at the product rule. The product rule is about multiplying two polynomials together and differentiating them. Let's look at it. If you are to differentiate two polynomials, say y equals uv, where u and v are the two different polynomials, then keep the first polynomial and differentiate the second, add it to keeping the second and differentiating the first. Let's look at what this means. In our first example, we are given two polynomials to differentiate. So the first bracket is x plus 5 and the second bracket is 3x minus 2. To differentiate this, just differentiate the first bracket. That is, differentiation of x will give you 1 and differentiating of 5 is 0. Use it to multiply the second bracket. Then go to the other side by addition. Differentiate the second bracket and use it to multiply the first bracket. Follow the rest of the examples below. Now do this exercise. Let's now look at chain rule. The chain rule is used to solve polynomial in a bracket with a power. So we treat the polynomial inside the bracket as u or a letter. In this example, the inside bracket is x plus 2. So we let u equals x plus 2. Then y will be u squared. So we now have two equations. U in terms of x and y in terms of u. So the rule says differentiate dy du, that is the one written in y in terms of u, and then differentiate du dx, that is the one written in u in terms of x, and multiply the two. In our first example, the inside bracket is represented with t and y becomes t to the power 6. So when you differentiate each equations, you will get 2x plus 5 and 6t to the power 5. So using the chain rule, we have 6t to the power 5 times 2x plus 5. Finally, you replace t with the inside bracket. Now let's look at our second example. The inside polynomial is x squared plus 5. So u becomes x squared plus 5 and y becomes u to the power 8. When you differentiate both of them, you will get 8u to the power 7 times 2x. So when you replace u with the inside bracket and you simplify, you get a final answer. Please follow the rest of the examples and try your hand on the exercise. Now let's turn our attention to the quotient rule. This rule is used to differentiate the division of two different polynomials. The numerator is represented with the letter, say u, and the denominator is represented with v. So you differentiate the numerator and use it to multiply the denominator. Then you differentiate the denominator, use it to multiply the numerator. You subtract the 2 and you divide it by the square of the denominator. Let's follow with the example. In this example, the numerator is 3x minus 4 and the denominator is 2x squared minus 1. So you represent the numerator with g and the denominator with h. So you differentiate g and use it to multiply h. You differentiate h, use it to multiply g. Then you divide the whole thing by the square of h. Follow the steps in each of the following examples. Now let's turn our attention to implicit functions. An implicit function is a function that y is not made the subject. In implicit function, differentiate each term, but a term with y must be differentiated and then dy dx added to it. What this means is that anytime you differentiate y, you add dy dx to it. So look at this example. In this function, there is y term at the left hand side. So you differentiate individual terms. Remember, when you differentiate y, you add dy dx. So the differentiation of x squared is 2x. The differentiation of y squared is 2y dy dx. And then you differentiate the other side of the equation. You make dy dx the subject, and that will be the solution. Look at the second example. Here there are two terms with variable y, and they are all at the left hand side. So you differentiate each term, but remember that every term with y, you differentiate and you add dy dx. Finally, you make dy dx the subject, and that will be the solution. Let's take our example 3. In our example 3, x and y are multiplying in the middle. So you differentiate the first x and then the last y. But the middle one, because they are multiplying, you have to use the product rule in solving them. Follow the examples carefully. To find the second derivative of a given implicit function, first differentiate it, and then your final answer, you differentiate it the second time. That is the second derivative. Follow the examples and practice the exercise given. We come to the end of our lesson for today. Thank you for watching.